Welcome to AI for Good, the leading, action-oriented, global and inclusive United Nations platform on AI. Organized by the International Telecommunication Union, the United Nations Agency for Digital Technologies, in partnership with 40+ UN sister organizations and co-convened with Switzerland. The goal of AI for Good is to identify innovative applications, build skills and standards, and advance partnerships to solve global challenges. In today's AI for Good event, we are counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished facilitators and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Hello, everyone, and welcome back to the Future Leaders in Quantum pre-hackathon webinar series. As a reminder, the hackathon will take place starting May 16th and is open to everyone with 4 distinct tracks, including art, education, innovation, and science. There'll definitely be fun and inspiring projects for all backgrounds and skill levels. If you're enjoying these workshops and are looking for some more hands-on experience, please head to the AI for Good website or visit www.quantumcoalition.io to pre-register for QC Flick. Today's workshop is for the hackathon's art track, titled Quantum Meets Creativity, Quantum-Inspired Art for Storytellers. We are really excited to have Professor Vishveshwara, a professor of physics at the University of Illinois at Urbana-Champaign, as well as a writer, a science artist, an educator, and a mother. In her research, Professor Vishveshwara studies quantum condensed matter physics, exploring the coldest states of matter, emergent behavior, and out-of-equilibrium dynamics, while creating innovative connections with quantum information science, biophysics, cosmology, and space exploration. She has blended these complex scientific phenomena with artistic expression through many projects, including the theater piece Quantum Voyages, the circus performance Cosmic Tumbles, and the short film Solaria, as well as by co-founding the Cascade Initiative to bring together art and science. Today, she'll take us on a journey into her creative process, illustrating how abstract ideas become tangible through art, offering fresh ways to communicate complicated science. Professor Vishveshwara, thank you so much for being here, and I'll let you get started.
Thank you so much for having me. It's an absolute joy to be here again. So let me begin with sharing some of the artistry right away in a moment, once I have this all set up. Yes, so this is the second in a series that I'm giving. And if you go back and want further inspiration, the first one that I gave was on using art and stories to teach quantum. And while I will build a little bit on the previous workshop, by no means is it necessary to have attended that one. Essentially, both of these are intended to really delve into so much of imagination and creativity that went into the shaping of some of the most profound ideas of our past century through the lens of quantum science and technology, and to really celebrate and connect with artistic expressions, both that went into creating this quantum revolution in and of itself, and also in seeing the wonders that come about when quantum science and art come together in confluence. So what I'll tell you about today, compared to last time's workshop, is really consider this workshop itself as a narrative, as a story, as I walk you through some of the pieces that we've brought to life, just as an example to inspire you into what is possible and to sort of give you maybe seeds of thought for how you might create your own story. So beginning with just looking at the wonder of quantum physics quantum science, quantum mechanics in and of itself, the whole saga of quantum and how it came to be is in itself a beautiful story, just starting from the early 1900s when people were trying to understand the nature of radiating objects, um, stars, heated metals, you and me, all of us radiating the same pattern of light speaking in different frequencies, of course, us in the infrared, stars visible there in the night sky, all of us through this black body radiation. How do we explain that pattern? And that was when Planck seeded the notion of the quantum by saying that the radiation light behaves not only as a wave, as was known, but also as bundles of energy, radiating as bundles of energy, giving birth to the quantum, giving birth to the photon. If you were to track the whole passage of quantum science itself, that is a beautiful story unto itself. And now you can see sort of the splendid things that have come about with communication, as is so crucial to the forum in which the hackathon is taking place, ITU, and the wonders that that has given rise to. Space exploration, all the way from space, where quantum science really is at work, be it the inside of stellar bodies or the beginning of the universe, all the way to the microscopic fragments that make us who we are. Here you see, for example, imaging of electron waves, lasers, coldest states of matter in the universe, Bose-Einstein condensates, probing the brain through MRI, quantum computation, and then, of course, this world that we live in, composed of you, me, nature, the earth, all built of tiny building blocks where the understanding of quantum physics is essential. So already here, you have a story at work. You have many, many stories at work. And take even a tiny bit of it, and you have in your hands the seed of a story. So now, as we are celebrating here today, this is part of the International Year of Quantum Science and Technology. You all, be you just listening or practitioners of quantum science and technology, or here to create with us today, you are all part of this celebration. And in this particular art track, I love the topic that is offered here as part of the hackathon, and it's to express quantum ideas through a whole range of different artistic media, music, visual design, storytelling, and in particular for this workshop, we will be focusing on the storytelling aspect, which will bring all these elements and theater and more into it. So before we begin, just to give you a sweeping view, this is something that I discussed in the previous workshop. So you can look at more instances of what we've done in our exploration. As Sean mentioned, Quantum Voyages is a theater piece that I will focus on. And April 19th at our Krannert Center of Performing Arts, by the time you hear this, that's when we would have performed it. It's been a beautiful journey of over 8 years. And today, this is what I will walk you through. How did we create this piece? What is the science behind it? What's the story? What's the confluence of art and quantum physics that went to it? This will be the topic of discussion today. But just to give you a taste of what I covered in the previous workshop, I talked a little bit about a course that we developed. And if you want to look there for inspiration and things to do, let me just say that the students, the teaching assistants that we have, they are so remarkable year after year, and the kinds of things that emerge through education, through storytelling, through the arts in these courses, thanks to these minds that are willing to just explore and imagine, it's really beautiful. And I know that it's there in each one of us, that desire to create, that desire to share, that desire to create stories and narratives. And then there's another piece called Quantum Rhapsodies if you want more inspiration. And then, as Sean mentioned, we also created a short film. So that way, I'll tell you a little bit more about it in just a minute or two. But this is something where you can actually go to the link. I'll share the link with you. And it's an example of what we've created that you can watch online, both to see how the storytelling happened, but also if you yourself had thoughts on what kinds of things you can create online. This is just one of hundreds of thousands of examples that are out there. Now, how did I get to do this as a quantum physicist? How do I get to do all this beautiful sort of exploration, which really has enriched my life so much? And in some sense, that organic approach that I'm fortunate enough to take in life, it's got such a tremendous sense of purpose, beauty, and I would say love as well, that it makes my life really, really complete. Not just my life, but it's a whole community that we've formed. And so let me just say that that's the life I'm living right now and loving it. And so how did that come to be? Just to tell you a little bit. So I used to do research during the day, condensed matter physics. Sean mentioned it a little bit, and I talked more about it in the previous workshop, so I'm not going to describe it in great depth. And then somehow there was always art in my life, and it would be, say, I just say 9 to 6 physics research and 6 to 9 the arts. It's not really true. Each one entwined into the other, and faculty life can be demanding. It rarely stops at 6 p.m. But nevertheless, I would always be doing art on the side. But writing was something that I always loved. And I never stopped from when I was a little kid. And then the other thing to realize is that as a scientist, one already has the arts within. We and I'll say a little bit more about that. When we do research with my students, we might have I'm a pen and paper theorist, as I like to say, and we do calculations. We look at strongly correlated quantum behavior, and it's extraordinary because it's really not only looking at the universe around us, superconductivity, cold states of matter, or even in space. We have collaborations aboard the International Space Station. But it's also looking at imagined lands. We're always thinking of what if, what beautiful states of matter can you have if you had thus and such ingredients, magnetism, liquid crystals, whatever it is. And so it's an extraordinarily rich world that we delve into as scientists. And ultimately, when we're ready to publish, when we're ready to write things, one thing that I always ask my students is, what is the story? And the story is important. Why are we calculating these things? What is the phenomenon there that sort of emerges up? And it couldn't have emerged in the past had we not gone on this exploration. So it's really beautiful what we do as a community of scientists, and in it is the art already. So I just want to point out that it's if you're a scientist in any form, already there is the art of story within you. Well, very briefly, there was a moment in my life where the floodgates opened to bringing art, actual art into my career as a scientist. And that involved a book I began writing with my father, who was a black hole physicist, one that just got published, Two Revolutions, Einstein's Relativity, told by him, and Quantum Physics by me as letters between father and daughter. Unfortunately, he passed in 2017. And so I found different ways of actually finishing our work together. Now, when we started this in 2012, that's when I really opened up to the fact that writing is so much a part of me. And he'd also been quite a beacon, a guiding spirit, because he was also a planetarium director, stories of the cosmos, myths from all different cultures, Greek, Indian, Chinese, all kinds of different Mayan, all kinds of different cultures come alive on the Sky Dome. And I'd watched him as a kid. I would go with him to the planetarium, see how he would script shows, bring together visual artists, musicians, and create this sort of world within the Sky Dome to enter into. And so that was really something that's home ground for me. He'd written books in the past as well. And then coming to what one of his all-time heroes said, this is Einstein here. Oops, sorry. This is Einstein here. And I think it's so beautiful because Einstein looks at art and science as branches of the same tree. And then it's really when we communicate through forms whose connection is not accessible to the conscious mind, and yet we intuitively feel it as something deeply meaningful, the mysterious, the hidden, and yet the essential. That is art, just that discovery in and of itself. And so I feel like that's a beautiful way to look at this confluence. And that's also been an inspiration for me throughout our explorations. So before I go into the theater piece, let me just say that if any of you are interested in looking at things that were created not just by our group, but many, many different groups, here's a link to a festival. It's called the Illuminated Universe Art Science Festival that we hosted in 2021. It's a virtual festival during the pandemic. And we had amazing contributions from so many different people. That was when my department head said, dream high. Unfortunately, it's this awful pandemic, but now we have the virtual world open to us, and anybody will be ready to come, almost anybody, if you just ask, if you present it in a way that'll draw them. And so we literally dreamed high all the way to the International Space Station. And so if you go into that festival website, you will see a conversation that kids had, including my son, who's very much into theater and the like, with an astronaut aboard the International Space Station. So it's, and just seeing that in itself, the awe and the wonder, that itself, I mean, not that we can get an astronaut from there every day, but that itself is a beautiful story unto itself. The piece that we created with my music friend Stephen Taylor, who's also on the faculty here in Urbana-Champaign, and who experimented with different genres of music, Western, classical, jazz, Indian, and you'll see influences of that in this piece. In this piece, Solaria shares the story of the spirit of the solar system. I won't give it away. Well, discovering humanity, how does it come to be, and all that, I will leave it for you all to go and explore. This came about because we wanted to celebrate the Earth, the solar system, the universe in some way. And instead of doing it from our perspective, as you might do in a planetarium or in a sort of documentary, we decided we'd play with it. And play, I think, is very important for anything, for science, for art. for life, the inner child in you. And so we decided to play with this notion of the spirit of the solar system. So instead of starting on Earth and going to space, we said, what if we start with space and somehow make the connection to these beings, to life that exists in this one little speck of space time. And so that was our sort of inspiration to create this piece. And so you have Solaria, which has narration, music, and visuals in it. So that's something I'll leave you with sort of a hint of that, and you can check out the video there. And so now it's time to plunge into the quantum voyage that I told you about. But I think, Sean, this might be a good time to pause and see if you have any thoughts, if there's anything I should expand on.
Yeah, I think the way that you've talked about kind of the interplay between thinking about science and you mentioned this idea of imagined lands and looking at the story in your research, and something that I've seen through my research as an undergrad is that like my background in music is really kind of driven the way I've thought about problems. So I was wondering, in your research, have your artistic experiences or background actually inspired new research directions?
Yes, yes. And I think that's a great question. And it's beautiful that you're already starting early, because I should say that back then, when I was an undergrad and a grad, I didn't quite have that boldness to have artistic practice driving scientific exploration. So I really commend the fact that you're opening yourself to that. And that's something that we do in our courses as well. That course that I told you about, the interdisciplinary course. I will say a few words about how it's influenced my science. But before that, let me just, because you're a musician and also looking at quantum computation and the like, let me just share with you one other instance of that. And in the last version of Quantum Voyages, I'll talk a little bit more about the music. We have an incredible group put together by Stephen Taylor, the one, my collaborator who I mentioned, and one of them, Xavier, uh, he actually built something called a spin doctor, and it's amazing. It's so it's an advanced version of a theremin, which is this haunting thing that is played where just through hand motion you can create music, and it sounds really spooky. It's almost like a human voice, and it's beautiful. It's haunting. Xavier took it to a whole other level where he uses what's called the Hall effect, and through magnets and the like, he can actually sort of create even more musicality through this physical setup. And what's amazing is he is very interested in representations of quantum physics, and in particular quantum algorithms, so Shor's algorithm, whatever it is. And so he has a way where he can program these algorithms into the sound that's created. And just audio, in terms of audio, it just sounds beautiful. It's like nothing that we humans might create. But the other amazing thing is you start picking up patterns. For example, prime numbers, that's a big part of it, as you know. And so then when you hear the audio for it, and the ear is, of course, very sensitive to relative frequencies and harmony and discord and the like. And so we started talking a little bit more about that and saying, can there be more complex algorithms, or can this auditory way of let's say processing the data, this auditory and aesthetic way, can that somehow bring about the next level of algorithms, for example, And so that was fascinating. With me, you'll see that with Quantum Voyages, we started exploring some of the deeper implications of quantum physics. Anthony Leggett, Tony Leggett. Uh, he's my one of my mentors and colleagues here. He's a knight, knighted by the Queen, but he's looked at fundamentals, macroscopic quantum realization, and the like. And I never paid much attention to sort of the meaning behind it, the philosophical implication, and a lot of us physicists don't. But right now, in a sense, with the second quantum revolution, interpretation is also very important. So it's really wonderful the way, um, building the next level quantum computation, sensing, whatever it is. Now you can invoke things of the past. What is the meaning behind it? Schrodinger's uh, cat, let's say, or the multiverse or observation, Copenhagen. And so one of the things that I'm becoming much more mindful of is these kinds of things, connecting those older philosophical outlooks to, okay, here's a qubit, it's functioning, and then you have it interacting with light, let's say. All these questions, quantum voyages actually inspired me to understand those better, and definitely quantum many-body phenomena. That's the bread and butter of what I do. Nothing like having a group of people in the room moving around, interacting with each other, and with parallels with the quantum world. So it's like there's kinetic energy, there's frustration, there's attraction, there's all kinds of things, there's community. What do they evolve into? And once you see that live, much more than a computer can simulate or equations can do, there's a whole other kind of understanding, and there's a lot of what if ideas that come about. So yeah, thank you for that question. Anything further, or shall we go on the voyage?
I'm excited to get on the voyage.
Okay, here we go. All right. So, and then just to mention, at the end of it, there was a wonderful circus group also that got involved, Le Petit Cirque, Natalie Eve Gaultier, but that's at the end of our journey. So let us start at the beginning. And it's really, just celebrating mystery and imagination and doing it through storytelling. So quantum voyages, it's the story of two voyagers entering into the quantum realm, guided by the spirit of wisdom. And this is an adventure, the creation of it that I took up with theater maker Latrell Bright. She is bright, she's brilliant, and now we've become such amazing companions on this journey, which has gone on since 2017 or 18 or the likes. That's a whole story as to how we connected, but we decide. So we've scripted quantum voyages. It evolved through every iteration, and when I started doing it, the son of mine that I mentioned, he was in the Nutcracker. And, I've also been very inspired by epic journeys like Ovid's Metamorphoses, maybe, or the Odyssey, or Mahabharata, whatever it is. And there's always this notion of these oftentimes these voyagers going through different lands, which are fascinating, maybe foreign to us, but just beautiful. And so I thought, in the Nutcracker, they're going through the land of snowflakes and Turkish dancers and things like that. So why not go through the land of light and photons, or battling the sea of electrons that's inside us, that's inside metal? So this fascinating quantum realm that we know, and then there's all kinds of craziness that goes on, the multiverse, and of course, when we look at things like Ant-Man, let's say, or so many other quantum odysseys, there's a lot of play on that. And as a scientist, what's amazing is, one, I can keep the scientific accuracy, which to me is very important. But two, we've seen the edge, the frontier of the craziness that's possible. And what an amazing thing to be able to depict that on stage. So this is the story. And now what I'll do is I'll tell you about its creation and I'll tell you about the actual story itself. So it began. So the Krannert Center for Performing Arts. What's beautiful in at our university is we have um, the northern part and the southern part of the university. And generally speaking, there's more engineering and some physics on the northern part, and then south has the arts, just very broadly speaking. Physics sits right on the edge, and 2 blocks away is the Krannert Center for Performing Arts, so I would always, be doing my calculations in the day and then hop over and watch a beautiful performance in this amazing space. And more I got connected. And then finally, in a fit of madness, I guess, I would just look at operas and just these theater, dance, and I would think, how wonderful would it be to actually script something? And the great thing is, when you're really excited about something and you propose it, by and large, what I've found is people don't say no. They don't say yes either necessarily, but they don't say no. And that's great. And it's like naivete and enthusiasm, let them take you forward. This is how I've managed to do a lot of things. So then, they said, well, you have to come up with a proposal. And so this was the original proposal. And then that's when I met Latrell. She'd also met my father, and we'd mused about what kinds of things we could do. And Latrell said, well, yeah, there's opera and all that. Have you thought of street theater, And I said, no. What is that? And so, I mean, I knew what that was, but it hadn't crossed my mind. And she does devising work, and I couldn't have asked for a better blessing because here she was. This was part of her blood, what she does, devise new pieces. And so then when I shared this idea with her, we said, let's go, let's do this. And it was so beautiful. We would be maybe at each other's house or in some beautiful, inspiring location. And so we developed the storyline, we developed the storyline, we scripted, and even the scripting, that exchange itself. And, she says we're all storytellers, in the sense of what I already told you. Each of us has a story to tell, be it in your practice, be it in your life, your culture, be it the story of the universe. We all have something to offer. And what she does is bring out the story from within you in this beautiful fashion. And that's what this collaboration ended up being. And so you can see we imagined, collaborated, scripted, and then we would workshop it. So we would get a room full of people, have them get up, share, embody this, read the script. So also talk about the science, and then bring it to life on, well, not on stage, but just in a room. And then you would see so many new things evolve, everything from getting the science accurate to the humor to just movement, the story, all of it. And so much developed also with people who were ready to go on this adventure with us. And then I will tell you more about the casting, the production, and flight because we've done it 3 or 4 times now, and each one has been a different adventure. So that is a taste of what we did. And so let me tell you a little bit about, we'll talk about the beginning, and then I think, Sean, would be a good time before I go into the entire story to see if there's any other things that pique your interest that I should talk about. So, as with so many stories, the story of quantum physics is this, it begins with light. And as I told you already, and so it felt appropriate to to start with light and what does it mean to see? What is light? Is it a particle? Is it a wave? It does depend on how you see and all of it. And let me just say, let me just point out here, this little thing that you see on the right, that's one of my doodles. And so for me, it's the story of two voyagers, Terra and Akash, led through these lands by the spirit of wisdom, Sapienza, and the names too have their origin for various reasons. And for me, Sapienza was some Grecian character like this, ancient Greece. And then Luttrell said, wait a minute, I don't know. I mean, if you think about it, quantum physics began in the 1900s, early 1900s. What about something more modern? And one of the people in my taking my course also decided to think of things like costumes. And it was absolutely brilliant because she looked through the times. What were the appearances, the characteristic appearances of these scientists and the like? And then many of us, we love steampunk. And so finally, this was the first Sapienza that we had. And you can see she does have this jacket and the steampunkish kind of look and goggles. And we were also inspired by Amelia Earhart, who was the first woman to make a transatlantic flight. And so all this just seemed appropriate. And then you can see the two voyagers in our first iteration, all lovely, lovely actors who really, really got into the role. The next one was a piece, the next scene is Quantum Clue. I won't go into it much yet. I want to tell you another big element of our production, and these are what we call quantum sages. These are real life physicists that come onto stage anytime there's some strife. And so in opera, you have this thing where everything's going wrong. It's terrible. There's imminent deaths and destruction and everything. And then there's this deus ex machina, this thing that just descends from the sky, bearing some divine being that saves the day and changes the course of the action through some miracle. Instead, we have our quantum sages. They share their wisdom. And so, be it voyagers drowning in the sea of electrons or light, even trying to understand what is light, how do we go to the next stage? So we have real life physicists, and we want them to emerge as they are, just who they are in all their unique, diverse voices and practices, and share their wisdom. So here you see Gina Lorenz, our first sage of light. She's going to be performing, she's been performing with us for most of the productions. Brian DeMarco is an ultra cold atomic physicist. This is a scene on the coldest spaces of the universe. And it's been marvelous. These sages, they get so into it. And not only are they the leading scientists, some of the leading scientists in the world who are doing amazing things. I mean, I'll give you Gina Lorenz's example. When we asked Gina, can you write Virginia Lorenz? Can you write something about light to share? And then this will be your monologue. And years ago, when we went up to her, she said, yes, of course. And then she showed us what she had, and she said, well, I wrote something in iambic pentameter. And we thought, oh my gosh, iambic pentameter, it's beautiful. And then when she recites it, the radiation quanta that you see in mirrored durations, colors, shapes, from depths of purest nothing came to be. I mean, it is so enchanting. And now in the new iteration, we have Stephen Taylor playing music where for entanglement, for example, he has two voices, a high register, a low register, and he plays with entanglement of these two things. And that's part of the action. That we also have a quantum ensemble. It's like a Greek chorus that accompanies the voyagers through their journey. They transform into light, they transform into other quantum beings. And so this is the full extent of what this creation has become. And I should just say, I know that this is too much to create within a month. But once you have the seed, you can create something really beautiful, really imaginative. And even if it's not a full-scale production like this, I'm just sharing with you all the different elements that went into it. And maybe something there inspires you. You could take a piece of it, and that within weeks could become something really, really beautiful. So this sets the stage, so to speak, for what the piece is about. I'll probably share with you the various scenes and the course of action, and that'll be, let's say, another 10 minutes. But before then, Sean, anything, anything to ask?
Yeah, I find the discussion about how the kind of the way that you mentioned you can still stay true to the science and still create like beautiful art. And I was curious as to how was the process of kind of balancing the details and the complexity of the science that you were trying to communicate, but then also, being free artistically to make decisions about, the story and perhaps the stagecraft. I think there's quite maybe a bit of tension in that relationship, but maybe something very interesting there.
Yeah, that's really great. First off, I should say, in fact, the scientific accuracy enhances the artistic dimension. And so when I tell you about the next scene, which is quantum clue, you'll see, all these different interpretations of quantum physics, Copenhagen, multiverse, when you understand them deeply, there's so much fodder for a good theater piece in and of itself. And so I'll say actually it's a plus, the scientific accuracy, because then, for example, if you know how electrons behave in a metal and you know it better and better, then just through embodying that, you know, you can do something beautiful and complex and something that couldn't have come out in isolation. So first off, I'd say that scientific complexity often is a plus for us. But then there are two, and actually, there's yet another thing I want to mention along the lines of your question. So first, I'll say the complexity adds to the beauty and richness, but you're absolutely right. At some point, you've got to give that up because otherwise, it doesn't work. It doesn't hold together as an artistic piece, or it could be just too didactic, or it could be whatever it is. And you don't want that. You want people to be inspired. And Tara is, she feels things in her bones. She's just like, woo, all the time exploring, while Akash is systematic method, like all about method. We want to say that you need both for both art and science because both have creativity, rigor, imagination, all of it, analysis. But ultimately, the audience is more like Tara because you may not be a practitioner of that particular thing, definitely not of quantum physics. And at the same time, we don't want them to walk away. On the contrary, we want them to be drawn. So they have to feel it in their bones. So at what time do you give up, like just sticking to that accuracy? And then at some point you let go. And a lot of times it's beautiful how Latrell, when she's in there directing, we're sitting down, we're having that discussion, spins inside an MRI machine. How do they move? How do they process? When she listens to the explanation I give, we both say that's great. And even the actors themselves, they say, the performers, oh, I can do this and this, and I know how to do this, and sometimes the embodiment itself, it could be hands, but right now we're doing it more like a West African influenced dance piece where they're moving their whole bodies. So, so these things enhance, but at the same time, you give it up. Like if it's moving your palms and there's some beauty, almost like a prayer, or there's this dance style, you say you bring in the elements of dance. I'm not going to really ask if spins are going to do that. Um, and then there's this thing where there's a point where Latrell says, okay, this is all artistic imagination, go. You don't, and whatever comes about, comes about. But another thing that I wanted to, another dimension is also how much of it is we're not just teaching in the standard sense. So the science is also bringing in another kind of artistic element. For example, you're watching Shakespeare, right? I mean, you could have all kinds of scholarly analyses of this, but an audience member doesn't have to go in with all that to enjoy it, right? Or even in the Nutcracker or the Odyssey, there's all this hidden imagery. So that's the other part too. We could be doing something very scientifically accurate, but it's not so important that the audience understands all the science. And that's where the art comes. It takes a different genre and it puts it there on stage. So, yeah, great questions. So, shall I take maybe 10 minutes to go through the course of the action? Okay. All right. So, I already told you it opens with light. And then the next one is quantum conundrums or superpositions or quantum clue. And it all began with, Latrell and I, we were in at my place, and my son had all these figures. As a little kid, he had the baby version of Clue, so the murder mystery game. No murder happened. Instead, somebody stole some chocolate cake or something like that, whatever it is. But we like the murder mystery game. So anyway, what happened was that I said, well, there's superposition. So an electron can be here and there and there and there. And then what does it even mean to be? That's a whole other existential question, but never mind that. And I said, until you observe it. When you observe it, it's only in one place. And so Latrell said, oh, you mean like in Clue? There's a murder that happens, and is it Miss Peacock in the dining room with a candlestick, or Miss Colonel Mustard? And it's all in the envelope, and only when you look at it do you know who the murderer is. But until then, there's all possibilities. And I said, you know what? We've got to have a scene with quantum clue in it. And of course, it's closely related to Schrodinger, because Schrodinger, we have this superposition of different things, and he takes it to a ridiculous extreme. And it was actually, a sort of jab at the Copenhagen interpretation that Niels Bohr and Heisenberg had. So Schrodinger's cat is, of course, very celebrated. And he did that as a parody. And so we said, let's start with Schrodinger. And so if you look at Schrodinger and the original cat paper, that is a piece of art in and of itself. It's so beautifully written. And this is the English translation. One can even set up quite ridiculous cases. A cat is penned up in a steel chamber along with the following diabolical device. And in German, it's even better. Höhlenmaschine. It's like hell machine or something like that, which must be secured against direct interference by the cat. And then he goes on to describe the imaginary cat experiment where you could have had an atom inside there in a superposition of decay and not decay. And if it decays, it triggers this vial of poison, and that kills the poor little cat. And so he's coming up with a situation where you can therefore have a superposition of a cat being dead and alive, which is absolutely ridiculous. And no cats have been harmed in this Gedanken of thought experiment, but it's actually at the basis of macroscopic quantum behavior and current qubits. Like, how far can you go with something being in two different states at once? So we came up with this clue game where we were able to, Schrodinger appears, he's the only dead quantum sage in our production. Well, dead and alive, I suppose, in our production. So one of the actors plays Schrodinger. But after that, Sapienza says, wait, let me explain what he's trying to say using this clue game. And so we're able to do the Copenhagen interpretation, where it's the act of observing that determines who the murderer is. We even have a multiverse version where there's a different murderer in each scene and a different victim. So we had a lot of fun with it. And of course, it's all in good fun. It's complete ham acting, and it's so we had a lot of fun with that. And this is the most complex scene. Later, we go into the coldest states of matter in the universe, these superfluids. And then we have, like I said, if you look at what's inside you, electrons are, so there's two different breeds of particles, bosons that are friendly, named after the Indian scientist Satyendranath Bose, fermions, named after Enrico Fermi, and depending on whether you have bosons, light, for example, is photons. They're these friendly breed of particles. Electrons are these unfriendly breed of particles. You have very, very different states of matter. And actually, if you look at the stability of matter, it's really comes about because electrons, protons, neutrons, they're all fermions. They're these unfriendly breed of particles. And so here you have the Voyagers battling the Fermi sea of electrons, which is really within metals, semiconductors, insulators, all that. But really in the metals, you see that the highest energy ones are the ones responsible for conduction. So you can see different versions. I showed you the first version of Terra, Akash, and Sapienza and the ensemble. This is our latest version. So you have Anita here, who's Sapienza, and she's got a really beautiful, jazzy, groovy sort of spirit, a lot of humor. And then Tara and Akash, you can see them here. And again, very, very different version from what you first saw. And this is from the original version where they're really battling the Fermi Sea and the like. And so the human element also develops. At first, Tara and Akash are like babes in the woods. As far as the quantum realm goes, it's new, it's refreshing, and there's this ensemble. But as they grow more and more, they themselves become bolder explorers, as does the quantum ensemble. But then the story also develops. So at first, oh, everything's great and it's harmonious, but then we have the fallout here when Tara and Akash realize their intrinsic fermionic nature, and there's a big fight that happens. And then how do they reconcile? This is where, we have superconductivity, which is a beautiful instance where electrons find a way of coming together and tapping into their friendly side, so to speak, and they form this friction-free, beautiful state of matter, superconductivity. So that storyline develops, and finally, there's a scene where an accident happens, and I won't give away too much. Tara finds herself inside an MRI machine, and Akash is outside, looking from the outside. And let me just say that when we depict the way the spins, so to speak, the little magnets in H2O and the protons in H2O within your body, the way they respond to this ultra high magnetic field inside an MRI machine, and the dance that they do, and the way radio frequency fields do a sort of call, and that's all the all that sound that you hear inside the MRI machine. And these spins within your body, depending on what's going on, is it white matter, gray matter, is it blood, depending on where they come from, they respond back in a characteristic way. And that's the beauty of how MRI works, and these incredible, gorgeous, life-saving images that come about. Let me just say it's the same underlying physics for a lot of quantum computation, manipulating qubits with magnetic fields and things like that. So that was part of the action. And so in the final scene, we do have a dialogue between Tara and, Tara and Akash. And just to show you a little bit, Tara and Akash, and this is the dialogue. which actually, and Sean, coming to your comment, in some sense, it very accurately describes the physics. I had the good fortune of, having as my colleague and mentor one of the founders, Charlie Slichter. So he told me all this in great detail. And so then we've put that into the script. And Akash says, in your chamber, magnetic fields piercing slices of you, points of you, fields of unique strength. Strengths are addresses. And Terra responds, my body inundated with water, every molecule, every H2O, every lone proton within, a magnet, a spin. As magnetic fields thread water, spins awaken, guided by the field thread, precessing, around a strong thread faster, precessing, around a weak thread slower, and so on and so forth. And the ensemble, they become doctors, then they become the spins within. It's almost like a prayer because it's a tense moment where we don't know if you'll make it out alive or not. So there's a big emotional moment in the scene, and you can see how the science, in a sense, also is part of the poetry of the moment. So this is Quantum Voyages in all its elements. And I know we've run out of time. So let me just say that itself had several journeys. We started for Tony Leggett in 2018 for his 80th birthday. Then we took it to Boston for the APS, the American Physical Society, the March meeting. And then we wanted to take it to UC San Diego and Santa Barbara. San Diego, where I was on sabbatical, Santa Barbara, where I did my graduate studies, and I'm totally in love with the Pacific. So, but then we know what happened in 2020. So the pandemic hit, and it was we had to go virtual, and it was just what a gift to have this in these hard times. And, these are the people we never met in person. Britney Spears, no, she didn't appear. That's just the wallpaper, Harry Potter. But anyway, this wonderful group of people that came together in the virtual world, and we were still able to make it happen. Along the way, Latrell and Steve and we brought together this over 100 of us fellow explorers, and we created this collective. And so that really sort of gave us a deeper purpose and direction and the like. This is a piece called Joy of Regathering that we did just after the pandemic. And now we've taken Quantum Voyages to the APS Global Physics Summit, where this was an International Year of Quantum. It was an offering. So Quantum Jubilee was a public event that some of us brought together there, and Quantum Voyages was part of it. And it's been absolutely a magnificent adventure. We had so much else also going on at Quantum Jubilee. So here you can see black hole physicists talking about the coming together, the merging of black holes and giving away ripples in space-time gravitational waves. In the opening video that you showed, I noticed also these beautiful dancers and perhaps something cosmic in the background. We did something similar where Le Petit Cirque, these beautiful, they're twins actually, and as we had black hole physicists, there you can see Barry, I think that's Barry Barish, maybe the Nobel laureate, Gaby Gonzalez, and a whole group of black hole adventurers. They came together, they were explaining all that happened, their journeys, their shared journeys as well. And then we had a poem of these black hole mergers when these circus performers ascended into the air and actually embodied that. And it was just absolutely stunning. So our play, our intersect between the arts and sciences, they literally can take us up there to cosmic heights. So hopefully and then as for quantum voyages, we still in about 4 days, which by the time you're listening to this, it would have happened already. We're set to perform it here locally, and we're super excited about it and the next journeys ahead. A very important next journey is going to be what you all create at the hackathon, and I will eagerly wait to see what you all come up with and what your story may be. So with that, thank you. And Sean, if there's any sort of parting comments, thoughts, reflections, this would be a lovely time for it.
Thank you so much for the fantastic talk. I've always been fascinated by, the way that art can be a really powerful communication tool for science. And I think I actually was at March meeting. I didn't get the pleasure of seeing your performance, but I know that there were a lot of conversations about how can we communicate science best, or quantum uh, in particular. And I think, there may be a very powerful role in kind of visual art and visualizing these ideas, like the way you discussed bosons and fermions. The way I learned it was very abstract, but perhaps it would be, more effective if we were able to see things like this and kind of visualize it in that way. So I think that's really powerful.
Yeah, and
Yeah.
one thing to add, actually two more things. One is, uh, in fact, I think art is really powerful that way. And it's amazing as to how it even reaches out to children. And one example of that is I learned so much more about our American history and Constitution through my son, because he would just be singing parts of Hamilton, and then I don't know much about Jefferson. I'm like, oh, let's look at it. I'm like, oh, wow. And then, the room where it happened, like, what was it that happened? And so that's an amazing instance where you don't have to know everything, but even a child can pick it up. And then you start sort of absorbing it, maybe dissecting it, maybe feeling it. And I think that's something, as you pointed out, Sean, just the way, what are these fermions, bosons? What do they do? And also visuals, words, all this. And there's a rap actually. Luttrell created a rap for the end, which just takes fragments of the entire piece. But now it's like our whole cast is just singing this rap, and it's almost like a benediction because it has rap, but then there's a sort of spiritual element to it. The music surges, that's how it ends. And so yes, I think art can do that. And the last thing I want to say is that when we do our practice, it's neither one serves the other. So it's not like, oh, art makes things pretty for the science, or, oh, science gives cool themes for the art. When there's that true confluence, when we come together in the room and we deeply listen, what gets created, you don't call it art, you don't call it science. It's just like this beautiful new thing unto itself, where it wouldn't have existed without one or the other. And I think there's something very beautiful in that. So yes, maybe this is when we bring our journey for today for a close and see what new journeys happen at the hackathon.
Yeah, well, thank you so much, Professor Vishwashwar, and thank you again for the amazing talk. To our audience, we look forward to seeing you again soon with our next pre-Flick workshops. And please check our website for more updates and pre-register for the QC Flick Hackathon this May. And we hope to see you all there.
Thank you for participating in today's AI for Good session. We hope you've learnt something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the e-shop, and build your personalized AI for Good program. Let's shape the future of AI for good.